Okay, before the break, we started looking at doing some a little bit of physics coding in our script. The big thing is setting up collections. Sort of this before taking this class, everybody had the intro to game development class. So uh, a game engine is a finite state machine. There are a fixed number of states that it can be in at any given frame. So really, what we do is we just check every state that it could be in, or at least the ones we care about. And when the engine is in a certain state, then things happen. So lots and lots of this. Right now, just check the input options. But as the games get more and more complicated, we have more states to check, like different positions, check out collisions, check timing events, and the game engine is just going to call this process or whichever loop process we use, function we use, over and over and over again. And every pass through it, we just check every state that we care about and respond, set up the response accordingly to what should happen if, like in this case, if the forward button is pressed or the backward button. Where do you jump? That's something that can happen, right? Input is action just pressed jump. Um, jump's going to change our y direction. So we set up another variable here for y equals 0. And if come over here, we can see from the way the arrow is pointing that our positive y is upward. So we need to set y equal to something upward. And we can multiply by an acceleration, like we saw earlier. That's one way to do it. We could also just go to the number we want here, right? Instead of doing -1 and multiplying that by acceleration, we could have just put acceleration here. So I'm going to do that actually. And then we don't need to multiply down here. So slight change in the code. But see how we either have one of those should be negative. Forward would be negative acceleration and backward would be positive acceleration, which is just the direction we're going in. Why we accelerated a different value though. I erased it from the board, but it was already, the force is already on there, right? So we know that our object has weight, has mass, gravity's pulling that mass down. That's what those two things together create weight. So we have to overcome that weight. So in this case, finding the numbers a little bit easier. On the last one, what we had to overcome was the force of friction pushing back against us. And without knowing what that friction is, because we haven't got to the physics material yet. It's in the reading assignment this week, right? Everybody see that? If you haven't read yet, it's in the reading assignment this week. But also this damping thing that has more impact over it, how much it slows down. This is would be more along the lines of air resistance or water resistance than friction, because the friction is kind of set in there at a default value, but it's in the physics material. One of the properties is becoming friction and bounce. It's in the reading assignment this week, so whenever you get to reading that. But here, all we have to overcome is the weight to jump upward. We know what the weight is, or can punch into the calculator really quick. Okay. Whoops. If it's 75 kilograms, and friction is pulling to 9.8, it's going to come out to 735. Or we can use 10, because that's really, really close to 9.8. So we need to come up with overcome 735 units of force pulling downward. So with setting y equal to 736, is that going to work?
Go to work, you jump very high.
Yeah, technically that is more than 735, so it's gonna move.
Mine is at 735 jumps.
That is the exact amount.
Yeah, I said it's y equals 735.
Okay, we might not,
And vector 3 is 0, y, z, and the mass of the thing's supposedly 75 kilograms. That's what it says. So
oh, so let's look into why that is. Okay. So we apply this force, which jumps way up there. Much higher than we would expect if we were just putting in the exact value that should counteract gravity.
maybe not just because the camera angle, but it sure to me seems like it jumps way crazy high. The size of the capsule.
So if we go over to the documentation on this and check that function. Central impulse. So it's applying vector 2, applies a directional impulse without affecting rotation. Is time independent. Applying an impulse every frame would result in a frame rate dependent force. It should only be used in one-time impacts. So we're pressing off. Yeah, and here's that thing. So this applies everywhere. Applying impulse. Oh, applying impulse is everywhere, and this goes backwards. I must have said that backwards earlier. It does a one-time thing, but it needs to spread out over time, so it happens repeatedly. So if we switched it to a force, is time dependent and meant to be applied every physics update. So, how much should this force be spread out? When we jump, remember, impulse has time, right? Is it coming along and pushing very slowly on something over time? Or is it just an instantaneous one? When we jump, almost immediately there's nothing to push against, right? So this, I was thinking I was hoping on my phone to go way back there from the words in the documentation, but those look kind of confusing. This one we might want to do as an applied force. So instead of so to apply a force and only jump, obviously the movement's going to be off now. It's not enough to do it. But that one time instantaneous thing, that's more like what jumping is, right? Whereas movement is spread out slowly. So probably up that just a little bit. Say 750. Now it's just barely overcoming gravity. It's barely wiggling. So increase that quite a bit. Take up the just pressed. from that documentation, I already closed the page. We need it to happen repeatedly. Right, we need, there's no time. There's no time built in like there is with the horse, if that makes sense, so.
So instead of jumping, this is effectively just, I now have rockets.
Yes, lifting. So I put it back to 735, notice I can't overcome, I'm equivalent to the force of gravity, so now as I hold it down. So we would probably, so to get that to behave accurately, it involves setting in other conditions, right? It's applying the force, it's getting faster and faster and faster. It's continuing to accelerate until we let it down. Not a very intuitive one. So sometimes it does come back to just working with the engine, kind of like we had at first. So it takes some going back and forth, right? So when we move forward, our estimate on how much force we needed was based off impulse happening over time. When we jump, it's based off the instantaneous manner, but they seem to behave in not like a jump. So that's why you want to spend a little bit of time kind of playing around with numbers and seeing what works. Applying an impulse is a better way to move, right? No, you just got way too much of a jump. It'll come down eventually.
Mine sets on rate 5.
That sounds. So, oh, I need to go back to just press. That's why. Is action just press? 20 is way too small. Go much bigger. And you just want to take some time and hone in on numbers like this. Probably don't want it to be able to keep jumping, right? That would involve checking to make sure the ground, see if the ground is there. There's a couple ways, easy ways to check that. What I like to do, well, when zoom buttons get out of my way. Over here on our object, just use a ray cast. So a ray cast object, I'll zoom in on it. See how we have that little blue line going down? If I change that to a different, so instead of maybe, let's add something in there. So now it's going off at 45 degrees. We're just looking off at some direction. So we want it to go negative downward, but not very far. So like, oh, I was going to put 0.1. So I'll go 10 centimeters. So it's only 10 centimeters long now, but think of it like a laser pointer. And that internal processing, that comes out to basic. That comes out to just one bit of processing. It's a laser pointer shining 10 centimeters over. And if that hits anything, then we can detect it. Remember the other day we set the ground on level 1.
And then I guess also you can adjust it so that if you want the player to be able to help them or something.
Yes, yes. So I want to prevent that. So let's go through the steps to build it up to it. So the raycast is gonna shine out 10 centimeters on layer one. And if it hits anything, then we want to do something with it, so need a reference to it. So I'm gonna, if you grab it and hold control and drag it over, it'll bring all this annotation stuff to set up with it. So I just clicked and then held down control and drag over. And I haven't done this on my Mac in a minute. I think this is one of the situations where it's actually hold control on the Mac, not the command, but if anybody's on the Mac, please check that, whether you hold down command or control. Because I think command is already occupied for stuff on the Mac, so they use the actual control button. So notice that created a reference to the raycast object, gave it a name and a type and everything. So now we can refer to it and I don't know, every frame we can just maybe put a print statement and see what we have to work with. Ray dot add exception, clear exceptions, collide with areas, collide with body, collision mask. Oh, so we know it's looking at the ground collision mask, so let's print out the collision mask and see what this looks like.
I didn't see the entire variable stuff.
Okay, well, that didn't help, so it's just printing out layer one.
But if you jump, does it end up stopping and then when it starts printing again?
That's a good thing to check.
Well, if it's not doing it, wouldn't it leave it blank there?
Yeah, it's gonna stop. It's gonna be hard to tell that it's stopped here. I guess I could do this. This might make it easier. So clear that.
Can I scroll over to the top of this? See
Oh.
if the
Oops.
stuff gray.
I'll move it way up so that we can watch for a second. You should be able to drag and drop that from the hierarchy. There's a lot to type.
People.
So on ready takes the place, the on ready annotation takes the place of what we would normally put in the ready function, the initialize function.
Okay.
So that just does our setup stuff. Creating a variable, call it array. A colon means setting the data type. So here's what data type it is, and then $sign, a $sign in front of the name here in the hierarchy is how we refer to those things. That's what all of those mean. All right, if I can. I can move this really quick. We can probably see that happening. Not make it full. Nope, it's still. Yeah, so it's just that's just showing what collision mask it is. We want to see what that ray is colliding. That sounds like a better method. Or we could check the documentation. Right, that's probably what we should be doing. Raycast. Pretty good.
So for this, if you're wanting to check if a variable is something, what do you use? This is or don't use stuff. Doesn't seem to work.
Is will work.
Is okay.
Prototype. If you hold control and click on the object type up here, where we created it, that'll open the documentation right here. So get a description of what it is, then see all of our methods. There's our properties. Add exception, clear exception, get collider. That sounds like it might be useful.
Well,
It returns an object.
what type is
What type is what?
what type does the ray return?
A raycast is a type of data type. So that it'll always be is.
Output.
Hmm.
Output.
Oh, so that's what I was looking for here. If we go over to the documentation, just hold control and click on it there in your script. This get collider that returns an object might be useful. Returns the first object the ray intersects, or null.
Things also. It's no, to do that. It's not the right type.
Oh, yes, it's not an integer, because ray is a raycast ID. It's a raycast object. So check those properties, look in the documentation, and you'll see what properties you have to work with. So this is what the comparisons you're trying to make. You can access each one of these things from the ray. But so that get collider method, that returns an object, so it makes sense that that's the object it's returning.
Slide with thought, so I guess that would be the actual.
So it says it collided to an object. No. It apparently stopped scrolling on me at one point. Well, that's no good. Shouldn't it shouldn't be hitting a null object. We can check if it is colliding with something. That collision mass value or collision mass value, collision. I'm gonna start that right on the bottom because that's what I was trying to build up. Trying to get to the get collider object. So I don't know why it says it's null, because since it's I know there's a way. I think I might on Raycast, highlight it. 0.1 might be too small. Or go half a meter. I still don't see anything underneath it. Oh, I went the wrong way. That's why. I had positive 0.1, so it was looking up instead of down. See, that's the little things that normally I would catch when getting ready and skip right over. But I like to throw the errors in class so we can go over how to fix them, how to find them, how to fix them, because that's much more useful than me just telling you avoid certain things or something, right? I don't know why this starts in such a bad spot. I need to go into settings and change that. Well, it still says it's null. Maybe I go a little bit further and see if it takes it this time. Look at that. The ground is on level 1, right? On layer 1. Recast. I'm having to look at every layer. Hit from inside, collide with areas with bodies. That works. Make it a little wider so we can see it. It looks like it's long enough. Oh, yeah, now we're hitting one of the The downsides of making it up in class, the reason I usually prepare ahead of time and it looks so easy when doing the code. It should be the get collider method. I'm not sure why that's not working. Or why it's returning null. Maybe if we try moving over to on top of this other box, oops, not the right cast. Or object over. So now when it falls down, it should detect that other box. Still just always null, even when it's in the air. So when it's in the air, this is what it should be picking up. So this is where we get into debugging stuff. It returns already the object or intersects. Or RID. So let's try that. Hit collider RID. And we'll print that out and see what that does. Hit collider RID. Maybe these things have an ID on them. Oh, there it was. Looks like it only had changed one time. So it was probably did the same thing all of those times it was detecting null. It hit that, and then it was passing right through it to the other side. Does that make sense?
So it seems for some reason Godot doesn't like while true loops. Because it just sits there and does nothing. Go close the thing.
I've used them before. See, I'm going to copy all those things it saw and see if it at some point detected NPC. Oop, Control F. Oh. So all of those object nulls that it was detecting were a little bit off. We can see the gate collider at one point returned NPC, which is the name of it, and then the data type for it. Oh, excuse me for 1 second. Thank you, Mary.
You're welcome. You safe.
Hopefully it won't be too bad of a ride
Get out, get there.
before it gets really bad.
Yeah.
Thank you. So that's another thing, right? Frame rates really throw us off. This was like a simple Python. It's really easy to, like, we set something up, do the print statement, and we get the output we expect or what we don't expect. But I closed that pretty quick and we got 159 lines. So 158 times it told us it was null, and one time it told us the ground was there. Or the NPC was there. So just kind of another one of those things to watch out for. Just because you look at that output and it looks like that. I'm going to type dot name. Name's a property every object has. And then I'm going to go back over here and move this over where it's going to fall on the ground. Null does not have a name, so we need to do a check. If ray.get collider if not, ray.get collider is null. then we'll print that. And that's a function, so gotta remember the parentheses. Oh. Do equals here? It's not. It's based off Python, so is usually works. Compares both type and type and value. So the equivalent of strictly equals in some of the other languages, if you've seen those. So if it's not null, then we want to print the name because null objects don't have a name. And we can see it did detect that it was on the ground. So, but only one time. So different ways to set it up. What I would do normally is just set up a variable. Variable, I don't know, can jump. Boolean equal to false. Or is it capital P? Okay, lowercase. We assume that we cannot jump. Okay, bag. If it's not null, and that name is equal to ground, can jump equal to true. And then we can just add that in here. And can jump. Does that logic make sense? Do you see how the process for getting there is kind of what I was trying to go through. Instead of just type this code, how do we figure out what code we need to type? Because that's the thing, that's the reason Godot, Unity, and Unreal are often spoken about together. They have different, they are very different things, but with those three game engines, along with the inspector panel being dynamic, which we saw up here, we just use that annotation export. The thing that those three game engines have in common with is that every word that you need to write the code for a game, or write your scripts for a game, is already written on your interface. You just have to learn how to read it or how to dig through it. Or in the case of Godot, hold control and click on it, and then your entire documentation is built in there. That's a really useful thing for learning. And build up those, right? You might have to search through a couple functions till you find the one that's going to do what you want. And as you read the documentation more and more over and over again, it gets easier to read. Starts to make more sense. And then this is really what we're doing with games. Probably would have seen that. It's a finite state machine. There's only so many states that the game can be in, and every pass through the physics engine, every pass through the graphics frame rate, we want to check every state that we care about and then respond accordingly. And sometimes it's sort of a long struggle to build them up. Right now, it hit ground, so that should have been changed to true. So I hit jump. Oh, I never changed it back to false. So, and can jump is true, then we want to set can jump equal to false. So we just get one jumping value. So the rake act might be a little bit too long. It looks like I'm able to double jump, but not any more than that. And then that's just honing in on the value. I can come back to the raycast and instead of looking 10 centimeters down, let's look 5 centimeters down. and honing in on the value that prevents it from being able to double jump. I can jump twice, but not more than that. What happened there? But, play around with those things, maybe set a bigger jump. Just the basic idea. It takes time to get used to practicing the things. Hopefully that path of figuring out what to put in that kind of makes sense. How do we look at the words on our inspector panel, see what we have to work with, our different nodes and stuff to build it up. Because at this point, you're probably still, yeah, the homework assignment this week and next week, the group project is probably still at a point where you could find tutorials to tell you how to do every step along the way for that, for what you need to do for that, right? But tutorials by their very nature only introduces. Really on the next individual project, it's gonna start to get hard to find tutorials to do the stuff we're doing the rest of the semester. Yes.
For the recast, there's a checkbox that's hit for inside, and I turn that on to allow it to jump. It's when the cast has been shrunk. Set currently to -0.02.
Which checkbox? Get from inside?
Yeah.
Oh, that makes sense. Yeah, so,
Because then it's not really.
yeah, anywhere inside the very box instead of just at the very edge. And then it can be a really short one. But yeah, it's honing in on those values and finding the exact one you want. We're restricted on time, so we're gonna go through the logic. We kind of mess around with that. Oh, then the two things I said I was going to look at, so we can only move forward and backward, can't we? There's no turning, so. I'm gonna move the object back to the origin, so I know where it's at. Where's transform? 0, 1, 0, or a meter above the origin. And then this one, and bless you. 0. We go probably jump on that, and then I'll add quickly make one more object just to see that thing I mentioned earlier. Another rigid body. Give it a collision shape. Okay, a sphere. That way, when we jump on a sphere instead of versus jumping on the square, you'll see the physics take start doing very different things. There we go. And shape will also be a sphere collision shape. This. We'll move it the other direction. Make it pretty. That way we can kind of see what happens when our character interacts with these now. One, that's probably not what should be happening, right? Those are rigid bodies. Seems like they should respond to the force we apply to them. But yeah, this is. I'm not even lined up with square anymore. What did I put reload to? There we go. Notice that we are still getting that full interaction. I don't know why those aren't moving. Did I set them with a really high mass? I'm setting it with a really low mass. Same thing on the other one here. We're now mass down to almost nothing. I was expecting that to like kind of be like kicking a ball. So we ran into something, there should be a force, right? I think in this particular one, I probably changed some settings the other day. And this,
So that's one way to rotate the camera, just accidentally end up spinning the thing because it runs into a very big heavy block.
I'll turn off this rotation. Let's see if this. Power character. And yeah, you'll get some odd things like this. Right? I only have the back and forth movement. But just because of where the center of mass is, it's doing all kinds of crazy stuff. It's trying to move around. But that's just the laws of physics applied as we do those movements. And when your game includes those, whether it's 2D or 3D, your players are going to feel more, feel like their intuition has more into the game. So you want to go in there, play around with those things, look at the methods, try different things, just go back and forth, get used to it, as opposed to using character bodies, which we have to code everything. You have to entirely code all the laws of physics, and some of the interactions would be missing, and it's going to throw off the character's intuition. They have to learn new intuitions for a specific game instead of using their own. So play around with those things, try to get used to where there's good movement, try to using apply force and apply impulse in different situations as time allows. Oh, I didn't see something. I didn't see. Yeah, that's a good question. I'm thinking they must be anchored somewhere. They must have a lock on them, but I wanted to wrap up at 305. So if I go to that, mass distribution, deactivation, say can't sleep. Oh, freeze was set to kinematic. Let's see if, or set to static. Let's see if setting freeze to kinematic makes a difference. No. Yeah, somewhere it's probably locked in there because I was definitely expecting it to move. None of the axes are locked. Probably on the right collision layer. Oh, it might be on the wrong collision layer. Because compare those collision layers, right? Our object is on number 2. No, because the wrong collision layer, we just passed through it. I'm not sure why it's doing that. That was not what I expected. Because it has a little bit of mass. It's like a soccer ball. When we hit it, it should it should move. So, yeah, there must be a checkbox somewhere locking it in place. But as time allows, play around with that stuff. It's not one that comes along, it takes a minute to get used to those, but as you see different things and start to get stuff working, it'll start to make more sense. Anything else out in here? So remember, I may be slightly delayed in emails. I'll get back to you as soon as I can. And I will be back home by Friday night, so be back to a normal schedule for Friday night. So a little bit of that. Also, in today's, the big thing from today's example is, notice it's very different. When I'm up here writing the code, without preparing the lecture right beforehand. I don't want to waste our time in class, so I definitely don't want to do that more than once in class, but I do like to show that at least once. Let me know, remember, let me know if you think you can make it in week 6 or 7, whenever we look, do the VR stuff. Because I need to know how many of the headsets to set up. Otherwise, a couple people asked to kind of split up in breakout rooms and take a couple moments, talk to your group, teammates, while we're all in the same place, which I guess is convenient. So, let's go ahead and do that. I'll stop the recording and open up the breakout rooms, and then you all can discuss discuss further if you want to. If your group doesn't need to meet, you feel free to head out after your group is done with that. So, let's see, this will stop the recording.